Welcome to .NET Conf 2018. My name is Scott Hunter, and I'm a program manager at Microsoft on the .NET platform. And I've got Mads with me as well, who works on our languages. And I've got Miguel with me as well, who works on Xamarin Mobile. So we are super excited to be here today. We have a lot of really cool material. I'm going to talk about .NET. Then we're going to have Mads come on and talk about C# for a little bit. And then Miguel's going to come in and talk about Xamarin and Mono and some other cool stuff that we're working on. So to kick it off, let's roll into this thing. Okay, so .NET. One of the mantras we've had the last couple of years is you can build any type of application in .NET, whether it's a desktop application, a web application, a cloud application, mobile, gaming. We just recently, earlier this year, added IoT support for .NET Core and AI support for the .NET platform. So we think that no matter what you want to build, you can build it with .NET. Really excited about the growth of .NET. People always ask me, hey, should I invest in .NET? Is it still growing? 1 million new developers in the last year. And so .NET is a super healthy platform and super growing. The other one is .NET Core. We shipped this a couple years ago. It's starting to mature in the .NET Core 2.0 wave. And we've got over 500,000 developers every day writing code in .NET Core. So we're super happy about that. The last time I spoke to everybody was around the Build Conference, and we were showing some previews of .NET Core 2.1. We shipped this at the end of May, and you can get it today. I wanted to quickly highlight some of the big things that happened in .NET Core 2.1. And you'll see here, we've always cared about performance in .NET, and we want to prove to our customers that .NET is a super fast platform. So there's a public benchmark, which means we don't, we don't run the benchmark, and we've been working to continue to make .NET work better in all phases of that benchmark. And so you can see here on the slides, plain text, we're up 15%. JSON, we're up 18%. Data access, we're up 147%. And the last one probably matters the most, because most applications actually are some form of rendering and some form of data access, and you can see these huge improvements in all of these. I actually have the benchmark running in my browser, and I wanted to highlight a few things in that benchmark real quick. This is round 16, the latest round of the benchmark, and I'm going to go to plain text. And what's interesting about plain text, if I scroll down here, you can see that we have ASP.NET Core at around number 11 in this. But you're going to notice that the top players here are all roughly at the exact same percentile. We're at 99 percentile compared to 100 percentile. The delta between ASP.NET Core and the top item is roughly less than 150,000 requests per second. So everybody at the top is super fast, and we're at the top of that. Now, what I said before is, great, plain text. Who writes a plain text application? Not many people. If I go to fortunes, this is the craziest form of the demo, or the benchmark. It's got web rendering, it's got data access, it's calling endpoints, and you're going to see ASP.NET is once again in roughly the top 10 in this. And this is where you saw that data growth, making our data performance grow is what helped us catapult .NET into here. So the thing I want you to know is if you're a .NET developer and you're using ASP.NET Core, you're using one of the fastest web frameworks on the planet. And that's something we care about and we'll keep working on. So back to the slides. What were the major features? And I'm just going to quickly go through those. We added a bunch of cool features in .NET Core 2.1. One was global tools. This is the ability to actually install command line tools right from NuGet. You can, if you're familiar with NPM, you could do npm install -g. That would globally install a tool. Now we have a .NET version of that same thing. So you can write a cross-platform .NET Core console application and install it with a one-line command on any device. We rewrote the socket layer in .NET, which is why you saw some of those performance numbers you saw in those benchmarks. But we didn't just focus on the server, we also focused on the client. We rewrote the HTTP client to be way faster. It's about 10 times faster in .NET Core 2.1. We continue to make .NET Core 2.1 more compatible with existing .NET, so there's a Windows compatibility NuGet package. If you're an EF Core customer, my favorite feature here is we added lazy loading. It's one of the most popular features in EF that our customers are using. It wasn't in Core. Once again, we're feedback driven. We took that feedback, added it to EF Core 2.1. Then in ASP.NET Core, there's been this huge push this year in making all websites HTTPS. And so ASP.NET Core is HTTPS by default. For the first time ever, we've allowed you to take Web UI and actually put it into a library, a NuGet package, so you can share it across multiple applications. And we have this really cool feature called HTTP Client Factory, which I'll do a demo in a second. And we also brought one of our beloved frameworks from the .NET Framework world, SignalR, is now available in Core as well. So let's jump here, and I'll talk about one more thing real quick. SignalR, as it RTM'd for Core in 2.1, we also know that SignalR, we always have customers call us and say, how do I build a really highly scalable SignalR? We have an Azure service that you can run your SignalR backend in inside of Azure, and you can just drag sliders to auto-scale that application, and we do all the heavy lifting for you. And what I'm super excited to announce today is on September 24th at Ignite, we're going to GA this service. So let's move on, and let's do a quick demo of .NET Core 2.1. So I mentioned this thing called HTTP Client Factory, and we always talk about it, and it sometimes I think confuses people because it's kind of a hard to see feature, and I'm going to try to dumb it down today and make it really simple for everybody to see. So I've got an application here, and it's got an API, and I'm just using the typical values controller that we give you in a default application. So it's not got it's not doing anything crazy. I've got a get method that just returns a value. So it's not very usable, but it's going to highlight the point. So let's take this API and let's start it. So I will just go over here and we'll say start without debugging. And the API is going to boot up and run. Now I've got a simple app, and I'm sure this app is very simple, similar to what you, the customer, is probably doing. And it's got this index HTML, CSHTML. And inside of it, it makes an API call. Let me just take that away. It makes an API call, so it's not anything crazy. And you have all probably done this. And this is great. I can run this application. And so basically, whenever the index page is hit, it makes an API call to that API. And I'm sure your applications do something like this, whether it's a desktop app, a web app. And you can see this works great. Now, I'm going to change things a little bit. Let me go back to my API, and I wrote this cool piece of code here. It's called a random failure middleware. And so what it's going to do, it's going to make my app fail randomly. And I want to do that because we know networks go up and down, connections go up and down, and you should make apps resilient to this. So I'm just going to add this middleware, random failure middleware, and if I scroll here, you'll see that all it does is looks to see if a random value is there, and it throws an exception sometimes, and sometimes it doesn't throw an exception. So let's restart this app. Oops. We'll restart the app with that middleware enabled. And now if I go back to my client app, you know, I assume everybody's going to expect what's going to happen is if I'm back in my client app, it's going to start failing occasionally. There you go. As I refresh the page, it fails. So what would you do as a customer? In the past, what you would do is you would go into your index page, and you would probably write some retry logic around this. Now that's great. You'd write this retry logic everywhere you call an API, or maybe you only harden one API or another API. Or maybe you write a wrapper around HTTP client that does this for you. And so what we've done in 2.1 is we've added the ability for you to set policies. So I can say add, let's go down here, HTTP client. And I can now, what I can do here is I can create a HTTP client factory. And what this means is I can create an HTTP client and give it a bunch of rules. And with those rules, I can define a bunch of stuff that you can do. So look here, add HTTP client, API, and then I say add transit error policy. So I'm saying, hey, I want to have an error policy. And what I do say is, I say policy retry async 6, which basically means if you fail, try again 6 times. Now you can set multiples of these. There's a whole bunch of these that are available. But by setting that line there, I've now got a set of rules that are applied. And then in my code, instead of creating an HTTP client this way, I can go and ask the factory to do that for me. Client equals factory, create client, oops. And I'm going to give it that name that you saw earlier, API, so it will look that up. And then so everywhere in my code, instead of just doing up an HTTP client, now I say factory, give me one called this, and those rules are applied to it. So I can now run this code again. And now, even with that API throwing exceptions, this app is not going to crash because no. It's complaining that the app is still running. There we go. Now we're going to run it again here. And I can refresh this as many times as I want. It'll never crash because I've set that policy. And so this is a great feature. You should be using it in your apps today. Set your policies. Don't write code around all these APIs. And it's part of our work to make microservices better in .NET. So let's move on. And let's talk about 2.2. So just this morning, we shipped Preview 2 of .NET Core 2.2. It's available today. You can grab it right now. And let's talk about some of the big highlights or the themes that we have in the 2.2 wave. One of these things is we want to make web APIs easier to build. Every app, whether it's a web app or a mobile app or a desktop app, is probably calling some APIs. We know this is an important area, so we want to make it easier for you to build APIs and to build clients that can call those APIs. You just saw with the HTTP client work we did in 2.1, we make it easier to call APIs. Microservices, we hear microservices all the time, and so there's a bunch of work we're doing to make microservice better in .NET. And we're always continuing performance, whether it's building your applications or running your applications. Those are the big themes. So let's go over some of the major features. Multi-tier JIT compilation. This is the ability for us to quickly JIT your application and get it running, and then to notice if it's actually hitting the same method a lot of times, maybe we should JIT it again and make a faster version of it. SQL connection with token auth. This is support for the first time to actually grab a token to talk to your SQL server from Active Directory. So you don't ever have to have any client credentials that are put in configuration files or anything like that. EF Core, one of my first 2 features are my favorites. Cosmos DB. We know that there's non-relational databases out there, and you might want to use the same EF programming model to talk to a relational database or a non-relational database. So you can use Azure Cosmos right from EF Core today with 2.2. Spatial extensions. This has been one of the most requested features for EF, which is spatial in this case is types for geographic locations. If you want to have a longitude, latitude, because maybe when you want to look at somebody's GPS coordinates and figure out where they are and run queries in a database, we've not had those in EF or .NET Core, and so those are both there. We have a feature in EF where you can actually point it at an existing database and it will make you a model. Now it has the ability to actually take views in that database and expose them in the model for you as well. So those are some pretty awesome features in EF Core. ASP.NET Core, we've updated all our templates with the latest versions of web frameworks, whether it's Bootstrap or Angular. Web API is one of my favorites. One of the common things that I get when I go talk to customers is, how do I secure an API? And so for the first time ever with 2.2, I think it'll be in Preview 3, we're going to have the ability for you to actually secure your API endpoints in the box. We've got support for HTTP 2. That's been a long request. Health checks. Glenn Condron's going to do some demos later in .NET Conf around this. This is the ability, if you're building microservices, to have checks in your apps or in your microservice for it to actually report whether it's healthy or not. Especially if you're running in a container infrastructure, that's really important. We've got a SignalR Java client, so if you want to use SignalR from Java, we've got support for that. So that's some of the major features. let's do a quick demo of .NET Core 2.1. So what I've got here for that is, there's a demo I showed at Build where we were showing how you actually can do diagnostics on APIs. And so let me do that here. So as we think about microservices, things that we think about in the team is how do we make APIs better? One of those things we want to do is we want to integrate Swagger into the API, so it actually gives metadata that we can use to provide a richer experience of building clients or debugging. The other one that I always have fun showing people is this is an API app. And so if I just run it in Visual Studio, you get this great experience of 404 because there's no web in there. And so we really want to fix this debugger experience that we have. So we actually have a global tool that will ship at some point in the 2.2 wave. And I'm going to switch my browser to be that global tool. That's as I was saying before, .NET 2.0 brought these global tools, and now you can actually, we're using them ourselves. So now when I run this application, and let's go look at the app real quick. I've got a controller here with a bunch of people in it. These people are obviously ranked in order, me, Hanselman, and Guthrie. And it just returns people. How would I test this API? Well, now that I've changed my browser to the REPL, here we are in a command prompt, and I can just do an ls, and that's going to show me the controllers I have. You can see people and values. If I want to get the people, I can just say get people. And if you look here, that goes and makes that request. You can see it brings Hunter, Hanselman, and Guthrie. I can do things like CD into people, and then I can just do a get. So we let you move around like you might want to. Great for testing UI or APIs. I can make changes. Just come back here, rerun those APIs. Maybe you like UI. I can jump right in here, go into the UI. Maybe I want to add another person here. Just type in .NET Conf, and I can basically say, try it out. That'll send that request, and I should be able here to say get people again. And there's .NET Conf. So the goal here is to make it easier to build and debug APIs with .NET Core. So let's close out of that. And let's move on. Okay, .NET Core 3 update. At Build, I was talking about .NET Core 2. When we first started it, it supported web and cloud applications. At Build, we talked about adding desktop applications, IoT applications, and AI applications. So we vastly are expanding the workload you can actually build on top of .NET Core. So let's briefly recap what happened at Build. I talked about adding support for WinForms and WPF to .NET Core. So for the first time ever, you can build desktop applications on .NET Core. We support a bunch of the other features that Windows talked about, XAML islands. This allows your apps to host any of the newer controls, the UWP controls, in your WinForm or WPF apps. We talked about XAML controls. This is taking some of the most common UWP controls and wrapping them up into WinForm and WPF controls. You can just drag in, so if you want a modern browser or modern media player, and high DPI fixes. We've talked about adding support for all the Windows 10 APIs into .NET Core 3. And finally, one of the bigger things we talked about that I'm really excited about is being able to do what we call the app bundler. This is build a standalone .NET executable that does not require anything on the machine at all. Simple self-contained exe that can run your applications. So really cool feature. A lot of people ask why? Why did you move these old frameworks onto .NET Core? First off, they're awesome frameworks. The big thing is you get all the .NET Core benefits side by side. You can run multiple versions of WinForms to WPF on the machine, and they won't break your applications. If you install a new version of WinForms, it won't break any of the other applications that use WinForms. You can have a machine global or an app local version of those frameworks. If you want to copy WinForms into your app, it'll use the one in your app. If you want to use a global one, you can use a global one. You get some of the core runtime and API improvements. This is Because .NET Core is side by side, we can make API fixes that we couldn't make in .NET Framework, and so you get those. And you get our really cool new version of CS Proj that you can edit by hand. So you get a bunch of these features. Now, let's talk about what's happened since build. WinForms is now available in our nightly builds. I don't recommend running our nightly builds, but if you go to github.com/net core-SDK, you can download the latest SDK from there, and once you do, you can actually just type .NET new WinForms. Visual Studio, the latest versions of Visual Studio now support building and debugging these WinForm desktop applications directly in the IDE. We don't have support for the designers yet. That'll be coming soon, but this is the next step. And then finally, we plan to publish a public preview later this year in non-nightly builds, so you can start trying to move your applications to .NET Core for the desktop. And so let's do a quick demo of that. So what I'm going to do is just go to a command prompt here, and let's make dir WinForms, cd WinForms, and I'm going to do something new, .NET new WinForms. Let's just drill in here and show that. Just like you can do .NET new Web, .NET new Console, well, now I can do .NET new WinForms. And after I do that, I can run .NET Run. There you go. And so I built a WinForm application in just a few seconds, typed a few commands, and boom, I'm in here and it's running. So what else can I do here? So let's load VS up. And what I'll do is I will come over here and I will open a new project. And let's go into that folder and open that CS Proj. Yeah. I might have to launch a new version of VS, but let's try it real quick. Boom. Okay, so you saw I could run it right in VS, but I want to show this is a core project. So if I go and edit my CS Proj, there's the .NET SDK, WinExe is the output type, .NET Core 3.0. It's referencing the desktop UI. Let's see what you can actually do here. I'm going to go into the form editor here, and I can come in here and say things like label1.text equals .NET Conf rocks. There you go. And to prove that the debugger works, I can come over here, put a breakpoint in here. So I've got a WinForms .NET Core project. My debugger works. I get full IntelliSense in the project. So we're making a lot of progress in this. And as I said, if you want, it is available in the nightly builds. You can just run over here and install the 3.0 installer from the GitHub page and try this yourself if you want. But full WinForm support. While we're sitting here talking about WinForms, I want to show one more thing about WinForms. At build, I showed that we had, one of the reasons you might want to run your WinForm application in .NET Core. So let's look at that real quick. This is the sample that I ran at the build conference. At this point, when we built this, you kind of had to hand build projects. You didn't have that support I just showed before. You could .NET new and all that kind of stuff. But I just want to re-show this to highlight one of the things that was really cool about that demo. And this is a simple app that we ran. Let's do this. And all it does is it takes a folder and it goes and iterates over that folder, and you can see it's showing me how much stuff's in those folders. And you can see this completed in 755 milliseconds. I also have a version of that runs on Core. And I can take that same folder and run that again, 282 milliseconds. So I'll bring these together so you can see them. The big thing here is the core version of this, you can see ran about 3 times faster, 2 to 3 times faster than the .NET Framework version of this. And this is because, as I said before, we've had time to go through and take some of the APIs and improve them. And with .NET Core, because it's completely side by side, we can not worry about compatibility the same way we have to do with .NET Framework. With .NET Framework, we're afraid to touch those APIs because it's installed on billions of machines and we can't break anybody's applications. With .NET Core, the customer makes the choice, the developer makes the choice which version of .NET Core they want to use. And Windows updates and updates to the machine won't break those applications. But you can see we made a bunch of progress since build. I can now build these things from the command line. I can open, edit, debug inside of Visual Studio. And you see that I get a big performance boost in these applications because they're running on Core. As I said before, we hope to have a public preview later this year where you can try these bits without running a nightly. And hopefully we'll get designer support in that time frame as well. I don't know, but we're working on it. And that's an update on .NET Core 3. So let's talk about Blazor. Blazor is a cool project that we started showing, it seems like about a year ago. And the version we showed a year ago was, we called it an experimental project. And what it does is it allows you to build client-side web UI in .NET. So we have lots of customers that might feel more familiar with C# than they are with JavaScript. They might not want to learn the JavaScript framework of the year, Angular, React, Vue, and they want to take advantage of the stability and consistency of .NET. So that's what Blazor was built about. Blazor used a technology called WebAssembly to basically load .NET into the browser. So we can actually run a version of .NET live in the browser, and so you have .NET running both in the browser, on the client, and on the server. And there's some cool benefits. Because you're running .NET, you're going to get native performance. You can share types between your client and server, and it requires nothing on the browser. There's no extension or plugin or whatever. It just works. And so we've been showing this for, I said, a couple months now. I have a slight update on this. What we've done is, as you show Blazor, and I'm going to do a demo in a second, the most popular part about Blazor is the programming model is just amazing. I can be in some HTML, and I can just call C#. I can use the skills that I already have. So we've decided that we're going to take that programming model and we're going to move it into ASP.NET Core 3. But it's a little different than the experimental version in that the experimental version, we're running .NET Core in the browser. The version that we're going to first start with, that will be in ASP.NET Core 3, is going to run that same code on the server. The programming model is exactly the same, so you don't have to change any code. I'll actually build a Blazor app in a second, and it doesn't matter whether it runs on the client or the server. You get this awesome programming model. And so the cool thing is, as we do this, you're going to be able to take advantage of this. And then in the future, when we have a version of .NET that we're really happy with running in WebAssembly, you'll be able to just change a few lines of code, and your app will then start running with .NET in the client, and you'll get even more performance. So super happy to announce this. And let's do a quick demo of this, because this is cool tech. So what I've got here is, I'm going to close these out. And I'm going to open up my Blazor app here. And I was sitting around, we were talking about what's a great way to show this tech. And so I wanted to take a common application programming thing that somebody might do today with some JavaScript and show you how you would rewrite that in C# and get the same benefits. So this is a web page. And you can see here in my web page I have an image of a bot. I've got a button here. And on click, it calls change image. And let's go look at change image. Change image is JavaScript. It's right here. It goes and grabs that bot element. So it goes and finds the bot here, the image tag. And it then goes and grabs the source attribute for that. And it says, hey, if that's got a 1 in it, replace it with a 2. If it's got a 2 in it, replace it with a 1. And so let's run this and see what this does. Oops. Still have my API client there running, so let's turn this off back to my browser. There we go. Run this again. And so this is going to come up, and if I click on this, my bot's gonna switch and do that all client side. Super cool. What would that look like if you wanted to rewrite that in C#? Let's try that. So what we'll do is we'll go back to that index, and first thing I want to do is I need to write some C# in this web page. So I'll create a functions block, and inside of this block I can write whatever C# that I want to write. So first off, we need a URL. So let's do string image URL equals, and let's just grab this image we already have here. That's great. We'll stick that in there. And now I need a method that will change this image. I need to do that same swap we were doing in JavaScript. So I'll do void change image. And let's just write it pretty much the same way as you saw it in the JavaScript. If image URL contains a 1, then what I would do is I would set image URL equals image URL dot replace, and I'll replace the 1 with a 2, and else image URL equals image URL dot replace, and we'll just replace the 2 with a 1. So I'm basically, every time the URL, we call this method, we look to see what URL we have. If it's got a 1 in it, we change it to a 2. If it's got a 2 in it, we change it to a 1. And we do that because in my app, I've got 2 images over here, a .NET Bot 1 and a 2. So here's just regular C#. Now what I would do is come up here and where I have this here, I'd erase this, and we'll just say @image URL. Typical Razor C# syntax. And where it gets kind of cool here is on this onClick, where I'm calling this JavaScript function, I will now add an @ here to call the C# function, remove those two, and now I've actually rewritten the same app that would normally use JavaScript to change the 2 images to now use Blazor to change those 2 images. So let's run this again. And it's complaining a little bit. Let me just cancel the build, rebuild again. There we go. I screwed up somewhere, didn't I? Yes. Left a semicolon off. So let's put the semicolon in here. Once again, same experience you would expect in Visual Studio. You can see it doing its stuff. And now that same app that I just showed before using a JavaScript function now does the exact same thing, all written in C#. So I think this programming model is amazing. If you're a web developer building Razor-based ASP.NET Core applications today, you're going to love this. If you want to write your JavaScript in C# or JavaScript kinds of stuff in C#, you now can do that. And as I said, it'll be a core feature of ASP.NET Core 3, and the ability to run that on the client using WebAssembly will be something that we continue to work on as we move forward as well. So let's jump back over here, and we'll move on. So the next thing we want to talk about is machine learning in .NET. The last couple of years, you read the news, you hear about machine learning and AI. They're hot topics. And at Build, we talked about wanting to build your own custom models. A great example of this, one of the demos we showed at Build, is our GitHub repo has tons of issues filed in it. And we looked to see if we could go build a bot that would actually go and take those issues and automatically classify them to the right areas. And in our case, we had plenty of data. So we took all the data that our team has done by manually moving those things over the years, ran it through something. So we took that data, and we then pushed it into ML.NET to build a model, and then we ran that model. And so I want to announce today we have ML.NET 0.5. You can get it right here. It's the latest preview of those ML.NET bits that we shipped at build, continuing to improve this, make it better, make it easier for you to use. Please go out and try this today. You can see that we've shipped 4 previews. There's a whole bunch of areas that F# support you can see here. We've got a bunch of samples, including that sample that GitHub classifier is now up there, and we're continuing to embrace this technology. A big thing about ML.NET that I like to tell customers as well is this tech is built on tried and true AI that we use inside of Microsoft. So if you're using Office or Bing, you're likely using some of the same tech that ML.NET is based on. And so tomorrow, we're going to kick off with a session on machine learning and artificial intelligence, I think with Ankit and Caesar. So you should be excited about that. And next, I want to bring in Mads to come talk about the new enhancements we have coming in C#. Let's go on, sir.
Thank you, Scott. It's going great. Let me just get the PowerPoint up here.
So if you don't know Mads, Mads works on all the managed languages at Microsoft, whether it be C#, VB, or F#. And today, he's here to basically show us some of the enhancements that we have coming in new C#. So,
all right. So first, let's talk a little bit about what we already did. So we went through no less than a slew of different versions of C# over the last year or so. We have what we call point releases, C# 7.1, 7.2, and 7.3. Looks like the slideshow went away there. Let's try again. Now I gave away my little unicorn there. So essentially, this idea with the point releases was to get better at giving you value right away rather than bulk everything up for releases that are further between. But we also had some concrete value around span of T and efficiency at the low level that we wanted to get in quicker. And so there are 3 sort of loose themes in these point releases. There's the safe, efficient code, which underlies some of the improvements we got on Tech Empower, for instance. And then there's just general more freedom, allowing you to do more things that were forbidden before, various ways of abbreviating things, the usual like little juicy features. And we're going to talk a little bit more about the safe, efficient code in a minute. But of course, we also want to talk about C# 8. The main theme here is it's going to be magical. I will, if the demo gods prevail, I will show a little of that as well in this keynote. So, but let's start out with the .NET with the C# 7.1, 7.2, and 7.3, and this theme about safe and efficient. So if you're writing sort of low-level code or you're trying to get performance, you essentially have to navigate between the Scylla and Charybdis. That is, garbage collection can be, provide an overhead and unpredictability of your performance at the low level. But if you try to avoid garbage collection and you start using structs and things that aren't allocated, then you run the risk of copying too much. And so essentially, we ratcheted up our toolbox for dealing with, for navigating these waters. And so Odysseus here is going to use span of T to navigate between the 2 dangers that lurk on either side of the strait here. And there are several language features that are there to enhance the span of T experience and help out with how you can write struct-based and array-based code without getting too much copying. So let's go and have a look at span of T. We are having a lot of flicker here. There we go. So span is essentially this idea that while .NET has arrays and they're sort of an efficiently packed chunk of memory, there's no easy way to refer to other chunks of memory, so to speak. There's no window onto contiguous memory the way that you might want. So here I have a simple program that creates an array, initializes it, and writes it out. And to show what span is about, let's just quickly look at array, and we see that there are some new extension methods here related to the span features in .NET Framework. So there's as span, for instance, here, so I can take the array and somehow get it as a span. So it should not click out of percent of view. Sorry, guys. Not in percent of view. Okay. I don't know why it's showing that thing. So tell me where to back up from. This always happens. I thought something else was going to go wrong today, and it still may. But for now, I'm back in Visual Studio. You guys are probably just looking at mobile development with Miguel de Casa or something like that. So give me a thumbs up when the code is up. In the meantime, I can talk a little bit about span of t without visuals. So the idea is that you can essentially, a span is essentially a view onto an array or a contiguous expansive memory. And so when you have a span, it's just like an array, but it lets you view the bits of maybe some other array or well, here we go again, of other memory that may be allocated in other ways. Okay, so there we are. So I don't know how much you caught here, but I haven't, let's just start from scratch with the demo. I have an array, I'm initializing it, I'm writing out the elements. Now I want to do some fun with spans. So let's take the array and look at the new extension methods that are on there. I can say as span. What I get back is a new type that is called span of t. In this case, I have a span of int. So let's write that out just so it's clear, though I'm normally a var lover. So now I have a span here. What you can do with the span now over the array is, well, obviously, if I initialize the array, let's have a look at what the elements in the span are. Let's try to run the program. See what the demagogues say to that. Oh, there we go. So you can see that even though I created the array, the span from the array before I initialized the array, the modifications to the array down here are visible through the span. So it's really like a window onto the same memory. Why is it interesting to see the same memory? Well, maybe I don't want to see all of it. Maybe I want to just, for instance, take a slice of it, and rather than copying all the elements that are in a given slice, let's say from element 3 and 5 elements, maybe instead of doing that, I want to just get a window onto it and not actually modify or create a new array, which is an expensive thing. So here we have a slice, and if we write out the elements of the slice, it should show just the elements that we're looking at. But the slice is still it's still a view onto the original array. If I go into the slice and say assign to the second element, let's assign 100 in there, and we write out the elements of the original span, say, then you can see that the fifth, or whatever it is, the sixth element of the span has been modified as well, because we're still modifying the same memory. So that's a very useful feature. There may be concerns about this whole, I can modify a memory through other objects. If you don't like people modifying it, but you just want them watching along, you can use a read-only span, which is just a version of the type that does not allow assignment. So you can see my modification through the slice here is now disallowed. So I can pass these out to others. They can observe my changes, but they can't affect changes of their own. So that's it for span. Let's return to the slide deck and hope that it projects. We're here and projecting. So, and talk about black holes, or rather, the scourge that has been writing object-oriented programming for many years, which is null reference exceptions. You can probably come up with others, but I think this is the big one. And we decided in C# 8 as part of the magic unicorn thing to help you avoid null reference exceptions. So this is where let's skip the slides and see if the demo works. This is where things currently, they came together last minute here. So we'll have a look and see if this works out. So first of all, I have a program here. I have a good friend, Miguel de Casa, who has no middle name, he assures me. And now I'm trying to get the length of his middle name by calling the get length of middle name here and simply returning the length of his middle name. Well, this looks like innocuous code, but it's going to throw a null reference exception. Because I'm getting his middle name, he doesn't have a middle name, so it's probably going to be null. When I access the length off of it, that's going to give us a null reference exception. Well, who's really to blame here? Let's go look at the person class that we created here. We can see that we have first name, a middle name, and a last name. But in the constructor that I use for Miguel, I'm only initializing the first and the last name. If only I had a feature that could tell me, whoa, they either tell me, whoa, you're not initializing the middle name, it could be null, or a feature that I could tell, well, I want it to be null. Well, that's what the nullable feature is about. And the way I turn it on is to use an attribute called non-null types. And when I put that on the module, you can see that I get a warning on the person class here, a warning saying you did not, let's see if we can hover over the warning here. It's saying you did not initialize a non-null field. So I can either, go initialize it, middle name equals null. I want it to be null. And then that warning goes away, but I get another warning saying you're putting null into middle name. So what's going on here? Why can't I put null into a reference type? Well, I can't because with the new feature turned on, reference types are no longer able to be null without warning. You get a warning whenever you put null in there. If you want to have null, you have to explicitly ask for it. So I can go here and explicitly ask for middle name to be nullable. I put a question mark on a string, just like you can today on an int or whatever, and I'm saying I want a nullable string here. It might be null. You see the warning goes away. Everything's hunky-dory with my person class. But now when I go back to my program and I have rightly specified that middle names might be null, then I get a warning here saying, hey, you may be dereferencing a null. And so now the feature is helping me push around where can there be nulls, where can't there be nulls, and making me correct my code. So what are ways I could correct this? Well, maybe maybe I have an if statement. Just think about how you would solve this bug if you got it from, like, say, a bug report from a customer where you had the null reference exception in production. So we can say if p.middlename is null. This is how you should always check for nulls now that you have pattern matching. Because it does not, unlike using double equals, it does not use overloaded equals operators. It always just checks for null. If p.middle name is null, well, then let's return 0, for instance. Now look at what happens with the warning. The warning down here goes away because the compiler does a flow analysis, and it knows that by the time it gets to this line of code, p.middle name is no longer null. So it's kind of like definite assignment, that it tracks the possible values of variables throughout the body of the method, and make sure that that when you dereference things, null is not one of the possible features there. or possible values there. So that's a quick glimpse at nullable reference types. And with that, I want to bring it back to my friend Miguel de Casa, who is waiting in the wings to tell us a little bit more about Xamarin. Thank you very much. Miguel?
Thank you, Mats. Well, this is one of my favorite features in C#. It's a gift of the gods. In this case, really a gift of Mads. So, anyways, well, Mads and the team, of course. So I'm going to talk today about mobile development and what we're doing there for you. We're here to give you. So here's a little bit of an agenda. I want to talk a little bit about our community, what we're doing to improve our community and our open source contributions. We'll talk about the Android platform, the Apple platforms, Xamarin Forms, and a couple of interesting things that are happening coming up. So so first off, I really want to thank everybody that has been engaging with us in our open source effort. As you can see, it has been an incredible year for open source contributions to the project. We only open sourced these three pieces: the Android support, iOS, and Form support. When Microsoft acquired Xamarin 2 years ago. So these numbers actually reflect the all time is just the last 2 years when we open sourced. But as you can see, it's there's a tremendous amount of energy and people contributing to the effort. And in Mono's case, you have to keep in mind that this only counts changes to Mono. But we are now pulling about 35% of the code now. It comes directly from CoreFX and Core CLR, so it's even a larger effort. Now, up until this point, you have to realize that when you work with these systems, we came from the Unix universe, and we're very comfortable using Emacs and VI. Make files and every thing that we do in the Unix world, but it wasn't particularly easy for newcomers to come in. It's an organic system, something that we've grown over the years, and it's easy if you were part of the community, but if you're a newcomer, it was difficult. So over the years, we've tried different things. In fact, this effort, an effort to improve the way and the easiness of building Mono started many years ago. My friend Jonathan Chambers, who now works at Unity, I found the first commit. In 2007, he contributed this change that allowed Mono to be built with Visual Studio, as opposed to this Linux toolchain that was ported to Windows that had an emulation layer for Windows and so on. So this effort started in 2007, and it actually took us 11 years to get every piece in place. But the outcome is fantastic. So these days, this is how you can build Mono on Windows. You just get Visual Studio installed. The first 3 lines there are just getting your gate checkout. So download your Mono and get all the modules in place. And then the next 2 lines, the first one builds a Mono runtime for Windows. It generates a native x86-64 binary. And then the second line builds all of the class libraries, so everything that you need, MS Core Lib, System XML, and so on. You see a little flag there called net4x. And that means that in this particular scenario, you are requesting to build the .NET 4.x compatible set of APIs. There's a lot more. There's the Android APIs, the Monotouch APIs, and so on. But what is really interesting about this is that every assembly now that is part of Mono can be built. It comes with a CS Proj, which means that you can open it on Visual Studio, you can build it. We do the dependency tracking. So, so what is really nice about that is that you don't need to worry about the chain of compilation, right? We will get all the dependencies for you. And these are just some of the other targets that you can use. And we support everything under the earth. Now, we really hope that this is going to make it a lot easier for people to come in and contribute fixes and improvements and tuning to all the mobile SDKs. So just a refresher of what we're doing, right? We're big into the native, into delivering a native experience for users. So that means native user interfaces. So when you create a button, we want to get a native button so that it behaves the way that user expects, it has the proper animations, proper colors, proper behaviors, touches, and so on. integrates with accessibility and so on, and every other feature in the US. We want to give you all the APIs that the platform offers. So on Android, everything that Google offers. On the Apple platforms, everything that Apple offers. So from .NET, you can use everything in there. And of course, we want to give you the best performance possible. And the last thing that we do is we try very hard. We work very hard. We don't try. We work very hard to deliver to you same-day support for these platforms. This past summer, we just shipped our Android support for Android Pie. So we have a blog post, we have samples, we have everything to get you started with Android Pie. And you can always count on that. In fact, today's a special day, and we'll get to that in a second. Now, at Build this year, I announced the support for accelerated Android emulation on Windows that work with Hyper-V, right? So some of you had to choose between Hexam and Hyper-V, and this year we worked with Google and we got the support for Hyper-V integrated into the Google emulator. I closed my session with this beautiful artwork that said, if you get the Windows April update, you're going to be super happy. Today is just the regular Windows update that you can use, and you should be happy. And I say you should because Spectre happened. And some of the mitigations that were rolled out for Spectre slow down the Android emulation. Now, the good news is that if you're trying some of the alpha, the previews of Windows, this is addressed. And we're going to have this, for those of you affected by the Spectre things, we're going to address that later this year. Now, now we wanted to not only improve the Android experience, right, the emulator experience, but we wanted to improve your life when you're building applications. And we've essentially looked at the problem from two perspectives. First, how can we improve the build times for you when you're building a new project and you have to rebuild everything from scratch? You do a git checkout and you got to build the whole thing. So we spent a lot of time optimizing every step in the pipeline, and we're looking at every step in the pipeline of how we can fix this. Some of these are fixes, some of those are optimizations, some of those are profiling, some of those are being smarter about the things that we do, and some of those are upgrading some of the tooling capabilities, some of them are skipping steps, some of them are avoiding slow processes. So we're doing a lot of work in that area, and we also want to improve your day-to-day developer experience. So every time that you make a change and you want to test it, we want you to get your code up on the screen as quickly as possible. Now, just so you get a feeling for how this works, this is not even a complete picture, but it gives you an idea. When you build an Android application, you need to package at the end a zip file that contains everything here that is blue, right? All the blue balls there. Those need to be shipped into the APK. Now, when your sources, right? Essentially, the user C# code or your XAML sources, they need to be compiled into your C# executable. Then we need to inspect it. We need to extract some Java data. Then we need to compile that data. Then we need to compile it to the native Android format and so on. So this is a series of steps that some of them are serialized and cannot be parallelized, and they can take a long time. So we've been tuning this pipeline, right? So if you make a change here, we got to run everything. If you have native libraries, Java native libraries, well, we got to extract those things. If you have native C libraries, well, we also got to extract those things, and we got to get them out. So, what is that thing doing at the bottom of the screen? All right, so we need to get all of those pieces in place, and we've been tuning this. So let me share with you some of the improvements that we're doing right now. So we're comparing the current stable release against the current master release of a fairly large application. This is called the Smart Hotel 360 app. Smart Hotel 360 is a sample app that we showed at Connect last year, and it's a relatively large application, 25,000 lines of C#. That's really not the large part, is for the sake of expedience and getting this quickly and having a lot of capabilities. This application actually consumes 99 NuGet packages. And this has everything under the sun. .NET Standard libraries, support libraries from Google, Google Play Services, Azure Services, Skia for rendering images, native code, everything really, and 32 XAML screens. And we cut down the build times from 2 minutes and 15 seconds to 57 seconds. So I'm very excited about what we're doing in terms of improving the build times. And all of this happens at the SDK level. So there's really no changes necessary on Visual Studio. It's all happening at the MS Build level. So all of these improvements will continue to trickle out. Now, the other thing that we realized is that when you're building forms applications, and in particular, if you're using .NET Standard for your shared business logic, okay. If you're using .NET Standard for your shared business logic, you don't need to run this process the whole time, right? You don't need to run the whole thing and repackage everything. So we've added a mode called fast development mode. And now we have a prototype, a proof of concept. And this proof of concept that today exists in a separate form, we're gonna integrate all of that work directly into our build system. And let me share with you what it is. The proof of concept is Xamarin Android Lite. And it gives you the ability of rebuilding your Forms application and deploy and run, right? So you make a change F5, and it's showing on device 3 seconds. It's 2.9 seconds, but I want it to be, I wanted to round it up. So it's about 3 seconds from a change to visualizing it directly on your device. So I'm looking forward to delivering all of this to you folks later this year. Now, as you know, today is an exciting day. iOS 12 is very likely going to be announced. We suspect that it will be coming soon. So good news, we have your iOS 12 support ready in store. And when I say iOS 12, I really mean the entire set of Apple updates that are coming today, which we suspect is iOS, tvOS, macOS, and watchOS. So that's what we internally call it Xcode 10, because it's the whole platform. But most people think of this as iOS 12. So we're ready for you. You should go and download our packages today and start spicing up your apps if you haven't started yet. There's a couple of really interesting things. So probably the one that my favorite feature, in my opinion, is support for shortcuts. This is a way that your application can participate in scripting in the system. So what is interesting is that now your apps can essentially describe an action of something that the user did, and you can, and this action, you need to provide it to the operating system. It's called, you donate the action, the intent. And when you donate this thing, this becomes searchable in Siri. It becomes something that you can invoke from Siri, but also, and this is the software programmer in me, you can actually script your application, so they can become part of this new shortcut application shipping in iOS 12, where you can script your app and call into your app. And we'll talk a little bit more about how you can do this, because you essentially need to, you give it a URL, sort of like deep linking, and then the operating system will call into your app, and we have something for you there. Then also ARKit 2 is coming out. We have some good samples for you, and what is very nice about ARKit 2 is that now it can detect physical objects and remember those objects. It can remember spaces, and you can have shared virtual spaces. That is also very interesting. We have great samples for you to try out. Our IDE has been updated to support these new capabilities. ARKit also supports detection of existing objects. So if you have a collection of objects that you want to scan, or pictures of those, you can build those in. And you've probably seen those demos in the past 6 months of people building recognizers for little cards or bills. So all of this is built with this technology. There's a new networking stack. This is an amazing networking stack that was introduced. If you're trying to do networking today, it's incredibly painful because you have to know too much about how the mobile world works. Disconnections, changing networks, changing paths, and so on. This is a callback-based system. Here's a little bit taste of what it looks like, but it's very interesting because not only does it handle connections, it also handles TLS, security for you, it handles bonjour, and you also get state transitions, right? So if your phone drops, if there's a connection change, if you connect to a new network, you'll handle it there. There's a lot more to try in iOS 12 today, so you should check it out. Now, let me talk about perhaps one of the most exciting things that we've been working in the past for you. It's called the Forms shell. And Xamarin Forms is a write once, run anywhere framework, and we give you a lot of tools. We give you every control that you can imagine, layout, function, and the problem sometimes is that as a new developer trying to create an app, it feels like opening a bag of Lego and with no instructions, right? And now you got to build a universe. So it is not unusual for, you have a goal, you have an objective, you want to build an app for your particular problem. And before you can get there, you need to figure out navigation, top menus, nesting, how to handle the back button, how to do searches, deep linking. There's all these things. And all we've given you, we gave you the pieces. We give you all the pieces, but we didn't really give you any guidance or how to stitch these things up. And even if you do, sometimes people make mistakes. It becomes bug reports and things that you need to fix and so on. Or you create, so you end up creating user interfaces that look like this, right? Beautiful UIs with italics where they really don't belong. There's these ideas for UIs that make no sense. Imagine, this is how I envisioned my first email program. It obviously makes no sense. I don't know whether there's a slider there. I don't know whether there's an arrow. Maybe it's something that you felt, looked good on the screen, or you saw it somewhere, or an emoji, and then this other control that you misuse the control, right? Instead of having buttons, you use this thing, and it's like inbox and trash. It's a selector. It's not a button. There's no action. And then at some point in a dream, you had this dream where you thought, what it would be cool if you could control the number of lines in the preview, and you make it 12. Nothing makes any sense. Your users look at this, and actually you just move on. You go back to something a lot simpler, like being a physics nuclear researcher. So we wanted to address this, and what we did is we built this thing called the shell. And the shell, it's an opinionated type that sets up, gives you a skeleton, a foundation where you plug in the pieces of your application. You fill in the content that we take care of the layout and of everything else. We give you a consistent look and feel. You can style it. You can style it either the hard way with XAML, or you can style it with CSS, and we take care of the rest. But we also take care of deep linking. So every page in the shell has a URL assigned to it. And we can launch the application directly into one of these pages. So by building all of this functionality in there, we're taking a lot of the pain away from you, and we're handling it ourselves. We also handle material, if you want to get a material look and feel on Android, which usually involves a lot of moving pieces and things that you have to do. So I'm just going to give you a quick taste of shell. This is what it looks like. This is a very simple application where we're trying to emulate with shell the Google Play Store. So you can see here that the different elements of this app. And if you look at the source code, it's actually trivial. It's very, very simple. All of these UIs are very simple to build, and I'll give you a little bit of a taste of that in a second. This is what it looks like on Android, and the same app. And here you'll notice that we decided to use a green tint, and the tint is shared across all of the pages, right, to give it a look, a consistent look to your app. We have the same thing for iOS. This is, oddly, it's the Android Play Store running on iOS, but you get the idea. And this is what it looks like on XAML, right? This is what it looks like on XAML. As you can see, you have a new top-level container shell, and then you have to fill in some of the details. You can see some pieces there, like the flyout header. That's what would come up if you press that hamburger button. Then you have your content for the top, for the bottom menu bar, and the items that go inside. The most basic app that you can build is this one, right? This is the simplest version of something that you can have. It has just one homepage. And in this particular example, local colon homepage is actually a type in your app, and this is what's being rendered inside. If you want to add tabs, all you have to do is add 2 sections, right? Very simple. The icon, the sections, and what you wanted them to be called. If you wanted to add these nested tabs, you can add them very easily just by adding the shell content there. And finally, these are all the idioms are already baked into the system, right? That you can build with shell today. Now, the other thing that we're adding to forms are 2 things that have been highly requested. The first one is the collection view. So we know that you wanted to have a collection view that goes beyond just lists. But we took this opportunity with collection view to actually make something of general purpose. So this can actually replace the usage of list view, and it has some much better performance characteristics than the old list view. And that is because we no longer use cells. Cells were a great concept, but it didn't really map well to the way that it worked. It was very expensive. So now you just use regular views and data templates. So some of you that had concerns about the performance of list view were addressing those problems with collection view by essentially eliminating the concepts of cells and going with views and data templates. Let me give you a little bit of a taste of collection view on this video that I have here. I hope I can get it to play. Yep, there it goes. So this is a new UI that previously was not possible to build with the built-in capabilities, or it would have been very difficult to get this sort of UI. You can have custom layouts, which I'm sure a lot of you would be very excited to use. And the other thing is, many of you wanted to have a carousel view. And it turns out that a carousel view is just a collection view with some good defaults in place. So this is a sample just of the carousel view, which again is just a collection view, but it has been customized to have this particular behavior. I want to close with two last pieces. I didn't want to get into every single feature of forms. There's just too many. This year, at the beginning, we launched the project F100, which was 100 paper cuts and 100 small features that our community wanted. We work with the community, and we've gotten a lot of those. It's a very, very long list of every single little piece. Keep those things coming. Hopefully, we'll get that to project F200 and so on. And finally, we're about to launch our Xamarin Essentials. Xamarin Essentials is the companion to Forms that allows you to abstract if you don't want to use the native APIs and you just want to have a nice cross-platform abstractions. It is our cross-platform abstraction for the non-UI pieces. So you should give it a shot. And that's it for the mobile segment. I would like to bring my friends Mads and Scott back to stage.
Awesome. Thank you. So I think, kind of in closing, we have, this is just the start of .NET Conf 2018. There's a bunch of awesome sessions coming up over the next couple of days. We were just looking at the schedule over there a second ago, and James on your team has got a mobile session coming up. Dan Roth's got an ASP.NET Core update coming as well. He's got a Blazor update coming. Diego on the team's got a EF update coming as well. So, and then we already talked about tomorrow. We're going to kick off with some AI with Ankit, and Caesar's got a section on that as well. So there's tons of awesome. And I'm skipping plenty of people as well. Kendra's got an update on what productivity features we have in Visual Studio. So there's tons of great content coming the next day or two or three. So please watch that content and enjoy being a .NET developer.
And I guess Matt has a session.
I have a session just after the break here.
Yeah.
And I don't know how butched up my demos came out online, but fingers crossed. If anything didn't go out, you can see them there.
And also on Friday, I have a session on retro.NET. So if you're despite the fact that I work with UIs, I still love the command line. So if you're into that sort of thing, I'll have something on Friday for you.
But lots of awesome .NET content coming. We have awesome .NET features coming out later this year. .NET Core 2.2, .NET Core 3.0 next year. There's just lots of good stuff. So anyways, if you're a .NET developer, please check it all out. Thank you for watching.
Thank you.